Hey, in this video we're going to be looking at proofs, specifically direct proof and proof by contradiction, as well as a brief introduction to proofs at an overview level. So what is a proof? A proof is a formal argument to establish the truth or falsehood of a proposition. Pierre de Fermat, probably butchering that name, but he says the essential quality of a proof is to compel belief. And in a proof, we take a bunch of premises and we build upon them to reach a conclusion and use our proof to demonstrate something new. Proofs are an integral part of postgraduate economics, and it's really important that you understand the different proof methods that are available to you, because it's not always obvious which one you should use, and some are more fitting to use in some cases than others. So having a general understanding of what proofs techniques are out there and when it's appropriate to use those proofs will help you along the way in coursework that require proofs from you. And the last thing I've written here is that actually when it comes to proof, everyone finds them hard, even geniuses. This is really important, just by the way, when you're doing proofs, to recognize that they are difficult. A lot of people will attempt a proof and fail on their first attempt and then think that it's a them problem, that they're not good enough. But in reality, that's what pretty much happens to everyone. And then the people who successfully do the proof do it on attempt 3 or 4 or whatever. So yeah, don't be discouraged if you're doing a proof and you're not sure what to do. That's really common. Okay, so what proof techniques are there? There's direct proof, which is the most straightforward technique. There's proof by contradiction, very handy. Proof by contraposition, proof by counterexample, and proof by induction. And the circumstances will determine which one of these techniques is appropriate to use. Sometimes you can use several techniques, sometimes only one is really going to work out for you. And in this video, we'll look at direct proof and proof by contradiction together in focus. Okay, so direct proof, this is pretty straightforward. It's deductive reasoning that shows you can go from the premise to the conclusion using agreed upon inferences. So for example, all elephants are mammals, all mammals are animals, and if those are things that we agree upon, then you can build upon that to say that all elephants are animals as well. And the idea is that you build upon your premise directly, linearly to the end to reach your conclusion. That is the most obvious proof technique and the most simple. But now let's move on to proof by contradiction. And I'm going to introduce a bit of a riddle, a quiz, and then use direct proof and proof by contradiction to prove the answer to this riddle. So let's take a look at it. There is an island with two types of people, knights and knaves. Knights always tell the truth and knaves always lie. On the island, you are approached by two natives. A says B is a knight. B says A and I are of opposite type. What are A and B? Now, obviously the first step in this riddle is figuring out the answer to it. But actually what I want to do is take it a step further and prove that the answer is true using direct proof and proof by contradiction. So if you're watching this video, before I go through the answer, I encourage you to pause it and then try and solve it yourself, which you can do now. And then once you're done, press play and we'll go through the answer together. Okay, so now that we're looking at going through the answer, step 1 in this type of question is just to figure out what the answer is and then more about proving it later. So let's grab some scrap paper and write out some things. Understanding this scenario here is that you've come across two people and they're either a knight or a knave. So realistically, there's only 4 options of what can be going on right now. And we can just create some scratch working here. Person A could be a knight, and then person B could be a knight or knave. So those are the 2 options for A being a knight. And then A could be a knave. And then B could be a knight or knave alongside that. And that's it. Those are the only 4 options that are going on here. And I think it makes the most sense to me to explore those options and how their statements hold up to just rule out, I guess, what's not happening. So let's explore the first one. If A and B are both knights, what's happening? Well, knights always tell the truth, and A says that B is a knight. That is indeed true, so that's fine. B says A and I are of opposite type. Uh-oh, that's not true. So that is impossible because they're not opposite type, and then B said they were, and he has to be telling the truth, so that can't be right. Okay, A is the knight and B is the knave. A says B is the knight. That's an instant fail because A is apparently telling the truth, but that is not true that B is a knight. A and B are both, A and B, A is a knave, B is a knight. A says B is a knight. Well, that's actually true, but apparently A is a knave, which means he's supposed to be lying. So that's impossible as well. And then lastly, they're both knaves. So A says B is a knight. That is a lie, but that's what you'd expect from a knave. And then B says A and I are of opposite type. They're not of opposite type, and so that's incorrect. And B is a knave, so that actually rings true as a valid circumstance. So now we know that they're both knaves, and that is the answer to the riddle. How would we actually formalize this into a proof, though? If we wanted to summarize this as an answer, you probably wouldn't want to submit just this scratch work as working out in a assessment, for example. So how could we formalize this? Well, let's do that. Okay, so a lot of what we were doing there was actually assuming something was happening. For example, assuming that A was a knight, and then logically moving forwards from that assumption to show that actually there was a contradiction and that it's impossible that that was happening, and therefore A could not be a knight. So let's do a proof by contradiction that A is a knave by first assuming that it's a knight and proving otherwise. And that will be the first step of our proof. So proof. Assume A is a knight. Okay, and we're trying to be formal here. So if A is a knight, what is the logical flow here? Well, if A is a knight, he has to always tell the truth. So therefore, A always tells the truth. Okay, and what does A say? Well, from the question, A says that B is a knight. So therefore, B is a knight, in brackets, as A says this. And from our line above, it's true, right? And if B's a knight, therefore B tells the truth. So therefore, B tells the truth. So therefore, this statement is true. So A and B are of opposite type. Therefore, A and B are of opposite type. As B says this. That's what I scribbled really badly there. Well, this is a contradiction because they're both knights, apparently. So we can say contradiction as they are already both knights. So them being opposite type is contradicting them both being knights. Therefore, A is not a knight, which means that A is a knave. So we're basically proving that A cannot be a knight by showing this logical flow leading to a contradiction, making it impossible for this option to be valid. Okay, so now that we know that A is a knave, we can do direct proof as to what B is based off what A says. So A is a knave working from here. Therefore, A always lies. So we can say, therefore, it is not true that B is a knight. That is the sign for the negation in logic. So therefore, B is a knave. And then that's it. I can say, as A says this. Brackets. Okay, so they're both knaves and we have formally proved it. The first part is a proof by contradiction, where we just assume something and then show a contradiction from that assumption. And then the second part was using the fact that A is a knave. The conclusion of this first proof is the beginning of our second proof, to just directly prove that B is a knave as well from that. And together that shows what an example is of a direct proof and a proof by contradiction. Here's the clean version. And just to wrap up this video, I wanted to take a deeper look at the logic of proof by contradiction. I'm guessing people who are watching this video have maybe used proof by contradiction before, but how well do you actually understand the mechanics of it in terms of logic? And I think as you advance in your economic career and do more rigorous proofs, it's actually important to understand why it is proving the thing that you're doing. So let's just finish this quickly with a look at this. So what did we do as a proof by contradiction? Essentially, we are showing that not theta implies C, where C is a contradiction. A contradiction is a statement that is always false, and therefore we're concluding theta from that. The reason why that works is if we look here, we've got theta being true or false, not theta being the opposite of that, contradiction being always false. If you do not theta implies C, just ignore that second squiggle, that's typographical issue. So if we look at not theta implies C, here's not theta implying C, so false and false with an implication in the middle is true, and then true and false with an implication in the middle is false. And this is logically equivalent to theta here. Theta is logically equivalent to not theta implying C. And if you look down at this table here, often what we're actually proving is P implies Q, like prove if P is true that we will get Q. And so if we sort of expand that out and we take our negation of this P implies Q statement, we have P and not Q. That is the negation of P implies Q. So this is looking at our statement theta being a implication statement, and then therefore not theta being this P implies P and not Q. And then P and not Q implying contradiction here is false, false gives you true there. True and then false gives you false here. False and then false gives you true there. False and false gives you true there. And then you can see that this is logically equivalent to P implies Q. So you can prove P implies Q by proving P and not Q implying C. And that is the logic mechanics going on behind the scenes when you do a proof by contradiction. All right, that's it. Final words for this video. Proof by contradiction is a great way to start a proof because if you aren't really sure what to do in a proof scenario, then in a proof by contradiction setting, you always begin by assuming the opposite of the premise. That gives you the first line of the proof. And then you also know the conclusion of that proof, being your contradiction. And you can put your assumption at the top and your contradiction at the bottom and actually work in both directions to fill in that middle part of that proof. And it's a great tool to prove things in particular. Okay, that's it. That concludes this video.